Welcome to the Hyperfine podcast. I am one of your hosts, Derek Padilla.
And I'm your other host, Zach Espley.
That was the most staged intro we've ever had. We've recorded a lot of episodes already, so you're hearing this out of order, but we're about maybe 15 or so around there, episodes recorded, ready to go. But this is our episode 0, just trying to introduce who we are and what the show's all about. So we don't always start in such a weird way.
Yeah, usually it's just a hello.
Yeah, exactly. But yeah, so I'm Derek Padilla, and I met Zach through working at a community college. So I was a physics instructor, and Zach was what was your official title? I would just say lab tech, but like what
the
actually
official
were you?
title was sounded weird. It was a student lab instructional aide, but I wasn't a student. It was for student labs that I was an instructional aide.
Yeah. SLEA. I remember that term now. Yeah, got it. So yeah, Zach set up equipment and did troubleshooting and helped students that were in the community college physics labs. So the classroom labs, doing fun experiments like rolling carts on tracks. With photo gates and stuff.
Lots of Excel, teaching kids to use Excel.
Computer. Yeah, probably more computer troubleshooting than actual physics equipment troubleshooting.
Yeah.
And you even taught some, like not supposed to, but did anyway, a little bit.
Yeah. Well, there were certain professors that sometimes showed up late or on rare occurrences, not at all.
Wow.
And I had to take over certain lab classes, but for the most part, it was just making sure that the students weren't hurting themselves or running or screwing up the lab too bad.
Right. No breaking of equipment, no electrocuting. Yeah. So that's where I met Zach. So I was a teacher there, and then we no longer work at that place, and it's Santa Rosa Junior College. We don't have to keep it a secret.
Yeah.
That's where it was, up in Santa Rosa, California. But Zach, where did you do your physics schooling? Like, how'd you? Yeah, let's go there.
Cool. All right. So kind of my background is, so I started at a community college, not wanting to be a physics major. I was actually really into chemistry, until I took a physics class, and then I just realized I love physics. I'm going to do physics now. So I transferred to UC Santa Barbara. And got my bachelor's there, left there, and then went up to Santa Rosa, where we met, worked there for a few years. Then I got a job at a company called Keysight, where I was a SEM, scanning electron microscope and focused ion beam technician, doing kind of failure analysis stuff. And they make, test equipment. So it was working with like little tiny transistors. And then there I ended up being an engineer for about a year. And I realized I really don't like engineering, at least, on a manufacturing line. It was just too high stress for me. So I left there, and now I'm back at UC Santa Barbara as a instructional lab manager now.
Nice. Which is a new title as of like a week ago or something, right? Like pretty recent.
Yeah. I recently just got promoted from a lab assistant to a lab manager now. Yeah.
Congrats.
Thanks. Yeah. And what about you? What's your background?
Let's see. I started with my physics degree as an undergrad from San Diego State, got a bachelor's. I toyed with the idea of going to law school and changed my mind pretty last minute and wanted to get a master's in physics instead. And San Diego State, they knew me, so I went in and said, "Hey, can I get a master's here?" And they said, "Yeah, take the physics GRE." Or did I even have to do that? I had to take the regular GRE, not the physics.
Oh, wow.
To get into a master's in physics at San Diego State. Yeah. So I did that, and started straight away out of my bachelor's into a master's. Did that for a couple of years, and then wasn't sure what I was going to do, but decided to get a PhD after that, which is a little strange. Most people go from an undergrad straight into a PhD program in sciences, but I wasn't sure. So the master's is kind of like, well, I don't know. I'm going to bide my time for 2 years and figure it out. And it led me to getting into a PhD program. I went to UC Santa Cruz, got a PhD in physics, doing solar cell research. So I was an experimentalist, and our lab kind of bordered material science and electrical engineering and a little bit of materials chemistry and physics, obviously. And yeah, so I got a PhD in, I think, 2013. And while I was wrapping up, I was deciding, a lot of people in my lab decided to go to work in, we were in Santa Cruz, so pretty close to Silicon Valley, and a lot of them went into industry type jobs. And so that's what I think most of the people in my lab group ended up doing. And I decided, my wife is a community college teacher. That's been her goal for a long time. So she was doing that, and I was like, that looks like a pretty good gig. And I really, really enjoyed teaching as a TA, and I actually taught 1 quarter of being a graduate student instructor, like not just the TA, but the actual lecturer person that was running the class while I was at Santa Cruz. And I really liked it. And I taught as an adjunct. I taught 1 class at a community college at Gavilan College in Gilroy, California, while I was a grad student, and wrapped up by applying to Santa Rosa and a few other places, and got a job at Santa Rosa Junior College as a full-time community college instructor. And I literally defended my dissertation, and 1 week later moved to Santa Rosa to start teaching. So oh, wow. It was a quick turnaround. Yeah. And so that was my path to teaching at Santa Rosa. And then currently, my wife and I both left our teaching positions, and we're being online entrepreneurs, as cliche and annoying as that sounds, but that is what we do.
Hey, no, it's great.
Yeah, it's like, I don't have entrepreneur in my Instagram bio or anything like that, but it's still teaching related. So my wife and I do teaching consulting for people who put courses online. So anyone who wants to build a course, we help them build it and get it out there. And it's not so much for universities or community colleges online courses. It's like an individual person who wants to teach, like, for example, not our client, but one of the biggest online course sellers, which I always give the example because it's so ridiculous, is how to hula hoop. And that just makes tons of money as the standalone course that people pay, maybe $20, maybe 50 at the most. And this person just sells a lot of them, and people pay $20 to learn how to be a hula hoop expert.
I mean, it looks pretty cool when you can get like the multiple hula hoops.
Yeah, exactly.
Maybe that's we should tick that off as one of our podcasts, physics podcast things to talk about.
Yep.
So I wanted to say that this podcast actually, not only did we just meet at Santa Rosa, this podcast was kind of born there. In that, you were teaching the lab course, so you'd be in the lab, and I'd be, in the lab supporting you. And so, once the students kind of got going, there wasn't a whole lot for us to do, with the students. So on the side, we'd end up doing like a little chalk talk on the, where whatever random physics question one of us saw online or thought of that day, we would just kind of, spitball about it for a while.
Right.
And I think that's kind of what led us to do this, right? At least that's
exactly. Yeah. There's a few times where we got a little carried away and like students were waiting to ask questions, but you and I were like, busily writing on the chalkboard and completely ignoring the rest of the class. Like you and I were arguing over something and getting into it. And we turn around and students are standing there like, we need help.
Yeah.
But yeah, so we developed the kind of, the mode of working where start the lab and then you and I would just be like, okay, what do you think about this? And then get into a question. And then it would turn into the chalkboard and we end up erasing student work, like what students actually needed to make room for us to have fun.
Right.
But we're like, we should bottle this and capture it, and decided to record a podcast. So the episodes we've done so far have started off, some of them are like that, like a little physics puzzle, like what happens when you do this, or how does this work? And then we also use this, since I'm not in physics anymore, I need a physics outlet. And so this serves as an excuse for me to go to the library and check out physics books and learn physics that I didn't learn in my PhD program. Since I was experimentalist, didn't get into a lot of theory. And so this has been a fun outlet to get into some stuff that I'm just curious about. Like we're digging into the standard model pretty deeply. And yeah, we had a decent episode on Bell's theorem, and some other fun physics theory stuff, as well as just like what happens if you pop a balloon inside of a balloon. So fun questions that we find on the internet and different books.
Yeah, and for me, I don't know if it's people that don't aren't physics majors. I don't know if they know this or not, but when you study physics, the way it's taught is here's like essentially mechanics, electrodynamics, and maybe some quantum one time through with, calculus, or like maybe not even calculus. And then you take it again, but this time you're going to use more advanced math. And then you graduate and you go into grad school and you take a lot of that same stuff again with more advanced math. So like you learn a lot of the same things, especially in your undergrad. Like your undergrad is pretty much just 4 years of learning the same things with more and more math to it. And so that's kind of where I stopped. So, it's been a while, so it's not fresh in my brain. So it's always good to review. But, outside of kind of your basic quantum mechanics and electrodynamics and classical mechanics, I don't know, there's a whole world of physics that I didn't get to delve into. And that's kind of what I get to do here.
Mm-hmm. Yeah. And I went through a PhD in physics, and I never took a class in relativity, which is bizarre, but it was always an elective that I took other classes. Like I took condensed matter physics. I took, computational physics, different electives that just always somehow skirted around relativity. Obviously, I know some relativity from modern classes and doing Jackson E&M problems, but I never took a GR course. So that's something, for example, I just don't know. So maybe we'll get to it in this podcast at some point. But yeah, so all my stuff, all my research, all my learning has been in the experimental and material science. So I did like superconductors for my master's, and then semiconductors, solar cells for my PhD. So it's always been on the electronics side of things, not cosmological, not like quantum field theory stuff. So I never got into that.
Yeah, and all that stuff I know almost nothing about. I know the basics, and I get to read up on it. Most of my background now is more like practical, lab type stuff, where I will that and physics education. I think that's one spot where we kind of overlap a lot. I think we're both very interested in teaching physics to people, not just learning it ourselves, but how do you convey this in a way that people can understand?
Right. And I at least personally, I look to people online, like science. I don't know what the term is, but someone communicators. Yeah. Minute Physics, Veritasium, those guys that have amazing YouTube channels that explain complicated things really succinctly. I think they do a great job. And so, yeah, if I could do 10% and have 10% of the reach as those people with this podcast, I'd be very, very excited. So I think it's just a fun way for the two of us to get together and jam on physics stuff, and then also get a little, have a little impact outside of our world.
Yeah.
Get people excited about physics.
It almost reminds me that I haven't actually listened to it, but there's a class online that you can listen to, and I don't think they have a video lecture. It's only audio from Berkeley. Called Physics for Presidents, I think. Oh
yeah, I've watched that, Physics for Future Presidents.
That's it. Yeah.
I've read the book too.
I didn't know there was a book.
Yeah, he has like a textbook that he uses in the class, and then he also has like a pop science book that's not a textbook, but it's pretty good. Mueller, I think his name was.
Mueller.
Yeah, Mueller. Not Bueller. Mueller.
Yeah. But yeah, like my understanding is that course is just kind of like, here's all the basics you need to know, if you were going to be president, about physics in the world. And I feel like that's kind of one of my goals here is to here's just some basic physics to people that don't know, physics. And here's kind of like some stuff you could know that will help you, when you hear a story on the news, like I think it would be awesome if you could understand that story better because of something that we, explained on this podcast.
Yeah, definitely. And also, I think if you're a physics major or even a physics grad student or just someone interested in physics after they've gone through their physics degrees and still want to dig into some fun physics stuff, I think this podcast is, it's made for me. Like, I wish this podcast existed when I was a student and listening to podcasts. There's not a lot of, I don't know, I've searched for physics podcasts, but nothing really hits at what I want out of a physics podcast, which I think is what this is just two people geeking out on some physics stuff and having fun with it.
Yeah. And yeah, I mean, there's like you kind of said, there's kind of the duality that we have, where we delve deeply into some topics, but then also some of the fun ones that I just really enjoy is just take a really simple phenomena. A lot of, I feel like 3 or 4 of our episodes have come from a GIF we've seen on Reddit, and then we're just like, what is happening? And we have to just like talk about it and come up with a theory to try to explain what's going on there. Yep.
Yeah, I think if you know of any good science podcasts, I'm interested. You can send them my way. But I think what makes this different, maybe there's another podcast that does this, but what I think makes this different is that we kind of are not structured. Like, we just loosely chat and like brainstorm and come up with stuff on the fly, which might be a turnoff for some people, but that's how I like to listen to my podcast, is just conversational people who can talk about stuff and feel really comfortable with it. So that's what I hope this podcast turns into, as opposed to what most science podcasts that I hear are. They sound really scripted, and they're going over news topics of reading Scientific American papers essentially on a podcast, which I'm not too interested in.
Yeah, I mean, there's other science communicators out that do that sort of stuff. So there's you listen to Star Talk and you'll get that.
I don't like that. That's not my style at all.
Right.
3 Blue 1 Brown, that guy, the math YouTuber, and I think Zach, you and I have talked about this off air, but he has a great podcast on math and math education. I guess not so much about math, but really math education. Yeah. That's the style that I really like, where I think it's 3 people in that show, and they just jam on math education topics, which is super interesting to me.
Yeah, I totally agree. Or I think like one of the early podcasts that you got me into was Hello Internet.
Yeah, exactly.
Which is very much that way.
Yeah, 2 dudes talking. So here we are, another 2 dudes talking podcast. Sorry, everyone. It's another one, but with physics. So that's what makes us different.
Yeah.
Yeah. I think to engage with the audience, Zach, we haven't finalized this, but I'm imagining a subreddit, and I already started one called the Hyperfine. So the podcast is The Hyperfine, and the subreddit is The Hyperfine. So I believe it exists. Let me go to the internet and see.
Dun, 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 dun.
Yep. There doesn't appear to be anything here because no one's posted anything, but it exists. So you can post there, and you could reach us on Reddit. And that's kind of a weird thing. Zach, what do you think about having a public Reddit account? Are you going to make a new one that's separate from all your history?
I don't know. I don't have a whole lot of posts on Reddit. Maybe. Okay.
Yeah. I don't know either. So we won't announce it here, but yeah, I deleted all my back history of shady posts. No, I'm just joking. But you can reach us on Twitter. I know that's fair game for everyone. If you want to reach me, I'm at, what am I at? I always forget.
Like Tortilla.
Oh, yeah. That's right. I'm at Like Tortilla. So Derek Padilla, Like Tortilla. So you can find me on Twitter at Like Tortilla. That's just also my Instagram account if you want to follow me there. Go ahead, Zach.
My handle is very, very boring. It's just at EspleyZak. That's ESPLEYZAK. Mm-hmm. Not very interesting.
Yeah. So Twitter is a pretty broad, easy way to get a hold of us. Instagram works for me. And I don't know if you're on Instagram, Zach. I don't follow you, so maybe.
I think I am. I've posted, I think, all of 2 sunset shots, maybe. So
nice. Yeah. And then, Reddit conversations. I like it just because it's like a discussion forum. People can post and have conversations without us having to interact necessarily. It's a little less pressure, I would imagine, because we have so many listeners. I know that it'd be better for us to have people talk amongst themselves and we can chime in, as opposed to adding us on Twitter every time they want to say something about the podcast.
Yeah, and if you have topic ideas and stuff too, like we're always looking for interesting things to talk about.
Yeah, definitely. And you probably hear some sirens because that's where I live. I'm in downtown San Diego, and there's a police station a couple blocks from me, so we get sirens a lot. So apologies. Can't do much about that in post. Those sweeping frequencies are not good for just cutting out.
Right. So should we end with a brief overview of what Hyperfine means?
Ooh, I did not prepare, but sure. Yeah. So the title, did I come up with it? I think I did. And
I believe it was you. Yeah.
I don't remember why. I was just thinking of cool physics words, and Hyperfine sounds pretty cool.
I thought it was because the two hosts were really attractive.
Oh, the splitting? Yeah, maybe.
No. Yeah. Anyways. So, yeah. Why, how did Hyperfine, you came to you?
Honestly, I don't know. I think it was just a word that popped in my head. I'm like, that's a cool physics term.
So what is the physics term?
So where does it come from in physics? It's it's usually talked about in the hydrogen atom, and I actually just explained this to somebody who's a complete non-physicist. So let me explain it as I explained to that person. If you know, so you have to start somewhere. So the starting point for us is going to be the planetary model of an atom, which is not correct, but it's fine. It'll get us close. Thinking about electrons in an atom existing like planets, like orbiting around the nucleus, which is like the sun.
Yeah, so, the Bohr model.
The Bohr model, yeah, exactly. So each electron is orbiting at a different radius, let's say, and let's take Jupiter. So let's say there's an electron in the Jupiter orbit in an atom. Now there's something, if you zoom in on the Jupiter orbit and you look really closely, sometimes in certain situations you can see that there's actually not one orbit, like not one lane for planets to go around there. Like Jupiter could be in one lane, but actually it's two different lanes and it splits a little bit. That's the fine structure. So there's like a Jupiter plus and a Jupiter minus. So instead of one orbit, you got two tracks that a planet could go around the sun on, or electron in this case around the nucleus. So you got Jupiter plus, Jupiter minus. That's fine structure. Then let's say you zoom in on Jupiter plus, and again you get really, really close to it, and you see that it's not actually one, it's actually two. So it splits again. That's the hyperfine structure. So it's one splitting turned into another splitting, fine, and then hyperfine. That's the structure of an atom. If you get into all, like, the way you learn atomic structure and atomic spectra starts with just the bulk basic lines, the structure. What's that called? Like the Rydberg lines. Remember that stuff?
Just the spectrum?
Yeah, you get your basic spectrum. But if you do some things like throw in a magnetic field or consider the electron spin
orbit coupling?
Yeah, coupling. So consider if you consider the electron's spin coupling to the nuclear spin, you end up with this splitting of energy levels. It doesn't actually just lead to one line in a spectrum. For example, it splits into two and then splits even further when you get more and more fine-grained detail.
To add to that a little bit, I'll add two things. One is there's also, if you zoom in on the sun, in your analogy there, you can get hyperfine splitting. In this case, the nucleus can cause hyperfine interactions when it's put into a magnetic field as well. But the spin orbit coupling that you talked about, to jump ahead, many episodes, that's related to something in the standard model that we'll talk about, or that nice. You'll hear about. So
yeah, we have a series on the standard model, a few episodes recorded talking about the different particles and fields and all the fun stuff that comes with it. So yeah, I'm actually don't know what you're talking about with the hyperfine structure in the standard model, but I look forward to it, Zach.
All right, cool.
All right. Well, yeah, hit us up on Twitter. I am at Like Tortilla.
And I'm at Esplizach, or find us on Reddit /r the Hyperfine.
Yep. Awesome. See you guys in the first episode.